send this out. So I know a lot of you have been working very hard on this, and some of you, you've been taking your time. That's fine, because the past couple of days, the lab and this isn't necessarily to get you to a solution, but to get you to learn the language of the problem. All problems, how do you learn, how do you get better at a programming language? By immersing yourself in the language. Same thing with let me just do this. Same thing with problems. You got to immerse yourself in the language of the problem. Right? Everybody says if you want to learn a language, right? They say, hey, you should plop yourself down in the country where they speak that language and immerse yourself in the culture and stuff. So part of doing this problem is to immerse yourself in the language of this problem, to understand what's going on, and what can be solved, and what things can be solved. We actually have plenty of people here, so let's go ahead and share screen. So here we are with our problem, right? And this is kind of where I feel that hopefully everybody's gotten to something that looks like this, where basically we have a default move over here, which could be random. I like to, what I found works really well is this default move right here. Return model.stay, okay? And by the way, my goal is for you guys to have this, if not finished, very close to finished today. Part of the reason is because with the with the online stuff, it's harder for me to give individual attention to every student who needs it. So that's why I'm trying to address a bit more broadly and give you maybe a few more hints than you would normally get in an online, than you would in person. So, so for an I model direction, we're looking in every, so this iterates through every direction, right? And we're saying, hey, if I look at the fox, great. Now I gave a couple hints. That I do want to reiterate here. The first hint I gave was basically that the fox code does have some useful tidbits, but reverse engineering it is kind of hard, is not exactly super useful, because the predator code needs to be a lot more complex than the prey code, because it's got to seek out and find it. The rabbit actually can be lazy. He doesn't have to seek out, he wants to avoid. So moving, which means I could move accidentally into the jaws of death, is not in my advantage. The second hint I kind of gave was, stay still and then dodge and then avoid line of sight. People also asked me if it was possible to get 100%. And the answer is there are two. I have had two students over the times I've given this assignment, which has been a couple of years. They've turned in a grade that gives you 100%. That grade, those assignments left nothing to chance, and they understood and it showed a deep understanding of the code. Simply put, the only winning move was not to play. So, so that is the only hint I am giving with them. With that. But otherwise, I'm going to show you where we can get with with this. So now so let's go ahead and just kind of look at this. If we see the fox, we need to be able to react to that. And one thing we could do was we can act like, let's just think about being dumb prey for a second. Let's just pretend we're dumb, because dumb is easy. What does a dumb rabbit do? It runs directly away from the fox, right? So let's do that. No, we don't need an if here yet. So we could do something like return model.turn. So model.turn is the big one here, right? I, which is the direction the fox happens to be in, and 4. 4 means directly opposite of that direction. So if this is north, it's south. If it's southwest, it is northeast. That's what 4 gives you. So let's go ahead and see how that works. Oh, I need to share my entire screen now, which means you get to see my amazing desktop. I worked very hard on finding a completely and totally original desktop. And I think you're all going to be thrilled with it. I hope you all enjoy my wallpaper. Okay, so let's see. Let's see. So these are some terrible examples here for this. Reset, run. So here, right, move run directly away, and it gets nommed. Let's see this again, because it's going to happen here again. Okay. Run directly away and get devoured by the fox. So what's going on? Why does my rabbit keep losing?
Yeah, it gets stuck on the wall.
It gets stuck in a wall, right? So it can't run away forever. And
it's also still in the fox's line of sight.
What could we do? So let's go ahead and run the grader just to see where our performance is. Well, at least we're cracking 1%. So there is that. So what direction would break line of sight? If the fox is at I and 4 is directly away, what is the direction that would break line of sight?
5 or 3.
5 or 3 or 2 or 6. Those are all good choices. So let's go ahead and test those out. So, right, let's go ahead and see what 5 does. And we're going to run the rabbit hunt first, and then we're going to experiment. So 5, right, is, by the way, and 5 and 3 are different. There is a bias in the fox code. So if the fox is in this direction, right, I know I'm being silly on video right now. The fox is on, then 5 would be that direction. So back and to the left for me. That would be that kind of move. So from my perspective. Right. So let's see how this works out for this rabbit. If it does, in fact, work out for this rabbit, because that is a tough position for that rabbit to be in. Let's see. So every time he moves, he's breaking line of sight, because remember, the turns are one after another. The rabbit escapes there in that case. It's actually doing pretty well. Gets very close. It's amazing. Remember, because those straight lines really make a difference. Let's go ahead and actually get that an actual quantity on that. 37% of the times, let's up this so that's less, so that we get get some good amount. 36, yeah. 37. Let's go ahead and up this to 30,000, because that will take about 10. That will literally take 10 times longer. Cool. 36. You know what? Let's do 3,000, because I'm about to do some experimentation here. So 3,000. So let's go ahead. The opposite direction was 3. Sorry, the other direction was 3, which is back and to the right. So let's try. Now, mentally, you think left, right, it doesn't matter, breaking line of sight. But we want to always verify our assumptions. Notice that back into that this direction gives us only 17% success survival rate. Does that make sense? Or everybody see that rather? This doesn't make sense necessarily, but what it is that the fox, because of the way he paces and the way he tries to go around obstacles and the way he decides what new direction to choose, he does have a bias in the way he turns. He has a bias in the way he turns. And going left apparently defeats that bias over going right. So if you have the choice of going left or right, you want to try to do that. What about going, instead of just going back and away, we just simply go perpendicular. We go perpendicular. So if he's forward ahead, I sidestep. Okay. So let's go ahead and see 6, which again is to the left. 28%, not as good as the 37 we were getting or the 36, but that's still pretty good. Okay, now part of the reason I'm getting caught though in these kind of conditions with 6 over here and run rabbit hunt is because, well, I only have one option for a move right now. Right, there were other escape routes, but I couldn't take them because I couldn't go in that direction. Makes sense? If I have a way to get away, I can, but I could only move in one direction. So I keep getting eaten. Thank you for computer for being so awesome about that. So, and also diagonal lets me move more directly out of his line of movement as well, which is good because he moves in straight lines, doesn't he? He moves in straight lines until he hits a wall, in which case he like bounces off of it in a random direction. So, oops. So let's go ahead and go back to here, just looking at this, right? So what do we want it? So we only have one option currently done. So we should probably fix that. We should probably open up our options. Okay, so that we can have more success. And so so how could we go about like, saying, hey, if I can't move this way, maybe try moving this way. How can I go about that?
Model that turn.
Well, model out turn gives me a direction. But I'm saying, is there something that tells me, let's see, did I get in chat? Can move. Yes, that's what I was looking for. That is what I was trying to, that was what I was trying to draw out. There is a method called can move, which says, hey, if can move, which is something that animals can do, you can say, hey, if this is a valid direction, it returns true or false. It's valid. If you can go in this direction, it's valid. If I can move, not I5, if I can move in this defined direction, oh, except I ought. So I want to go in this direction. Oh, that lined up very nicely. If I can move in this direction, do so. And need to close that brace up. There we go. So you could potentially stack these, right? You could potentially say, hey, if I can move in this direction, do so. Otherwise, try a different direction. So if you're stuck and have been stuck, I would try that. The results may surprise you. They may be extremely surprising. And remember, your only really bad moves, the moves you probably, so the only really bad move is to move towards the fox, right? And it's up to you as to whether you want to try to include moving away from the fox as well, or towards the fox, but at a diagonal. It's up to you as to whether or not you want to do those. And I know some of you are trying to avoid, being too close to the walls or the edge. Believe it or not, you really only care about that if you haven't seen the fox for a while. You can actually get up if you follow this to its logical conclusion with just dodging the line of sight, you can get 90% survival rate. How do you increase it? Well, at that point, you got to figure out why you're dying, which is that you're trapped, or that you're stuck, or you're against a wall, or the rabbit surprised, or the fox surprised you and you were not able to detect it, which happens sometimes just because of randomness. Okay. So the idea there is, but most of the time it's of your advantage to stay still, because if you move, the fox might see you before you see it. And if the fox has seen you, he'll make a beeline towards you, no matter, regardless of whether you've seen him or not. So really you only want to try moving if you haven't seen the fox in a while. Maybe then you can fix your position. Now, if you're trying the kite strategy, again, the idea here is once the fox is next to you or something like that, you can essentially get the fox in the loop. One particular fun way that's, and let me go ahead and boot up the rabbit hunt again and share screen there. So all right, and share. So this is for the kiting strategy. So one particular a variation of that is for students. They get their rabbit to find a bush, any bush that has full spacing around it. Okay. And basically they just simply just get the fox to follow it around the bush. And now how do you do that? Well, you play a bit of a dangerous game, but the idea here is that, and what happens a lot of the time is actually if the fox is here and you're here and you go this way, sometimes the fox gets confused and he'll like jettison off that way, which is pretty fun, or another random direction. It really depends, right? But the idea here is that once you're just playing, just going around in rings, you can essentially trap that fox in an infinite loop because he's the same speed as you. So if you're kiting, don't be afraid to get the fox to get right next to you if you're in position. That is a completely different strategy, and I find the other strategy to be much more effective and efficient. All right, so here's what's gonna. So, do we have any questions about this so far? Any questions that you want me to address before I break you up into breakout rooms, because that's going to be the next step.
Can I see the code? May I see the code again?
Sure. And I'll do you one better. I'll do you one better. It's text, which means I can drop it in chat. Okay, I suppose 4 is better than I suppose 4 is a couple better than 1. So only worry about the walls and the corners and edges and bushes and stuff if you're in the 85 to 90% survival rate. Part of this exercise is to demonstrate a few things. Okay. Problems in this class are often simpler than they appear to be. That is point 1. Point 2 is that point 1 only occurs if you spent a lot of time thinking about the problem. It doesn't come like naturally. The only reason I know I have an extremely efficient solution and it works pretty well, but took me a while to get there. And that just immersing yourself in the problem is kind of a requirement to understand those. So definitely start. So basically my, so when it comes to my homework, don't leave them for the last minute. Even if you don't work on it the first day, you definitely want to be thinking about it. Cause at least like feed it to your subconscious so it can problem solve. So how do I enable ligatures? Why did I close that? To enable ligatures, go to settings. And the nice thing about IntelliJ is that you can say, you can search for it. It's right over here. So if you search for ligatures, it will be right over here. You just check that box for the for some code that now the kicker here is that the code has to support coding ligatures. One of them is code that supports it. I use Fear Code, which was commissioned by Firefox for an operating system they were trying to make, and it didn't happen, but the font is still good. The Fira Sans font family that came out of that is actually used by the government of New Zealand on their official documents. No, the plus 20 points is not included on the grader when I run it. And if you're using this, also JetBrains, the company behind this, has their own code that uses ligatures. My personal preference these days is, let's see, it is Cascadia Mono. Which is developed by Microsoft. So, and I find this one to be good. Again, when Microsoft has been developing a lot of open fonts, open source stuff, so they've been very good about that. And that's been my preference these days. Now you might find it silly that I'm talking about programming fonts and stuff like that, but it's very important as a programmer that you have a font where you can recognize at a glance the difference between lowercase L and 1, capital O's, lowercase O's, and zeros. You have to be able to tell at a glance without any confusion what those are. Otherwise it just slows down your reading and your mental frustration. Let's see. Saving an image. Sometimes I get emotional over fonts. Yes, I agree with Kanye West. Okay. So, okay. Any other questions before I split you into breakout rooms? So what I'm going to do is I'm going to create, let's say, yes, you can do ligatures in VS Code. I'm going to go ahead and create 7 because why not? Breakout rooms, and you have the ability to choose your own room. Okay, and I will just simply go through them in a not at all random order. Oh, and let me enable screen sharing. Okay.
To the point that he got to.
Hey there.
So, hey, how you doing, Professor?
Good. Okay. So does anybody have any specific questions you want to ask, or anything you want me to take a look at now that we're in a smaller setting?
It's more so just like I literally got to the point that you're at right now.
Mm-hmm.
And I'm kind of stuck there because
Well, let's get you unstuck.
sure. The main problem obviously is
Oh, let me stop screen sharing. Oh, not screen sharing, recording.